ferns, honeycombs, a fern. So what I'm trying to kind of get into this is that every one of these has some kind of what we call a pattern to it. And when I see pattern, you can almost see that this has go this way, this goes this way, and they have a distinct pattern to it. If you look at like a honeycomb, like bees, um, they're very similar to this part right here, and you can almost see like this kind of goes out from a big, and it gets smaller and smaller to the teenier side. So this is what we call patterns. And so our topic for this one is going to be what we call arithmetic patterns. And so this is something I want you to write down, please. So we have patterns pretty much everywhere we look, and our brains think in patterns too. So in arithmetic sequences, though, a sequence is like a pattern. It's some kind of step-by-step process. So that's the first thing I kind of want us to define a little bit is what is a sequence. So yes, go ahead and write this down. So a definition of a sequence is an enumerated or a numbered collection of objects. Objects can be anything, in which repetitions are allowed and order does matter. No, order does matter in this. And so we have to kind of understand the repetition means right after each other. And we're going to see examples of this. So a sequence is just something that has a number of collection of objects in which some kind of repetition happens. So here's really a big, and maybe an easy representation of it. So let's say that I have a black pen, and the next thing I have is a red, a red eraser, a red pen. And then maybe the next part is going to be another black pen. So you can kind of see some repetitions here. We have black, we have red, we have black, and then here comes red again. So we have black, red, and that's your repetition. That's your sequence of a pattern. So here we go. So let's look at these three examples. Okay, and let's decipher what's going on with each of these, because that's part of discovering in math. You have to discover what you're doing. So this first one, we can kind of say, okay, 1, 2, 3, 4. Well, if you have the sequence down, what's the next part of it? So this goes 1, 2, 3, 4, and obviously 5 and 6, and it keeps on going. That's what we call a sequence. So we know that this goes adds 1 to it the whole time. We know that it adds 1 the whole time. Okay. What about this one here? This one here looks like, let's see, we got 2, 4, 6, 8, 10. Now it seems like from here to here it goes up by 2. Here to here it goes up by 2. Here and here it goes up by 2 and by 2. So this is kind of your pattern, your sequence. And when I say arithmetic sequence, well, arithmetic means addition. So arithmetic means addition. So this is going to go up by 2. So your next one will be 12, 14, 16. And it goes up by 3 like this. Okay, so this is not hopefully too bad. Now, what about this one here? Well, let's see. We have, looks like we have minuses or negatives. So from there to there, what's going on from -3 to -2? It looks like if you had the number line in front of you, it looks like it goes up by 1. Positive 1, remember. What about -2 to -1? Well, it looks like it's going to go up by 1 again. Well, what about -1 to 0? It looks like it goes up by 1 again. So each of these are going to go up by 1. So what's the next number from 0 and we add 1? Well, it's 1. What's the next number from that? 2 and 3. Well, what if I wanted to go the other way? Let's try the other way. What's -3? Add 1. Well, that's going to be, well, we're going backwards. So we're really subtracting by 1. So that should be -4, -5. So that's kind of like the whole idea of this. You're just trying to see what is that pattern? What is going on, that sequence? So let's keep going. So I want you to understand what a sequence is. Now, a sequence is a form of a pattern. And so please write this down. So a sequence, we have 3, 5, 7, and 9. And we have these three little dots that I wrote for you. Now, in English, those three little dots means that something repeats or goes on forever. Well, in this part, these three dots means that this goes on and on and on and on and doesn't stop. And so that's kind of what those dots mean. When you see those dots, it means it goes on forever. If you don't see those dots, it means it's going to end sometime. Or it ends. There's no sequence. So, for example, mine up here is that I have, technically I couldn't write 5 or 6 because it's not repeating, but the pattern is 1. Like, for example, here 2, 4, 6, 8, the sequence is 2. So really we just had to find out what is the sequence of it. It's 2. This one, I wanted you to go on a little bit. Okay, so now go back to this. So this goes 3, 5, 7, 9, dot, 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 dot. Well, this 3 becomes what we call the first term in the sequence. This is going to be the second term in the sequence. This is going to be your third term in the sequence. And sometimes these could be called what we call objects. They could be called elements. It really doesn't matter. So in our definition that we wrote up here, it says an object. Objects, well, these are the objects. These are the objects. These are the terms or the elements. So there's 3 different ways you can say this, and I will try to do my best and maybe stick into one. Maybe I will stick to one, just the terms. But some other books might call it elements. Okay, so keep going here. So this is something that I'm going to ask you to do for me. So please write this down. Given the first 3 terms, so given the first 3 terms, identify it as an arithmetic, then predict the next 3 terms. So what you're going to do is that I'm going to give you 3 terms. You're going to identify that there is a pattern, and then you're going to come up with the next 3. So here we go. You can stop this and, kind of pause it and go back into it. So look at this one here. So this has 1, 3, and 5. Well, what's the pattern here? What's going on from 1 to 3? It looks like it adds 2. What about 3 to 5? It looks like it adds 2. So I see a pattern here. I see something that's going on. So I know that this has the same pattern, and I want to get the next three terms. Well, what's the next three terms? Let's see. 5 plus 2 is 7. Plus 2 is 9. Plus 2 is 11. So here's your three answers. So now you can predict the same thing that goes on. Okay? Hopefully that's enough. It's not too bad. Well, look at this one here. Or look at this one here. Let's see. We have 2 to negative 2. Let's see. We have to really be careful. We have to think about our number line here. And our number line says that from 2 to negative 2, it goes up by 4 or down by 4. So if you look at your number line, it's going to go 2 here, and then where's negative 2? 0, 1, let's see, 1, 0, negative 1, negative 2. So it looks like it goes from 2 to negative 2. So how many does it jump? Let's see, how many does it jump? It goes 1, 2, 3, 4. But you're going backwards, so it's going to be minus 4. So that's there. Well, what about negative 2 to negative 4? Well, let's see. Negative 2 is here, and negative 4 is here. So we're going to go 1, 2. Uh-oh. We're going negative 2. So you see how this and this don't match? So no pattern or no sequence. It's not arithmetic. It might be something else, but it's not, in this case, what we can do. So we can't really predict the next answer without some information. So look at the next one. Well, this one says I'm going to go negative 1, negative 2, and 3. I don't really see a big pattern here. I mean, from negative 1 to negative 2, it's going to go down by 1, correct? Remember, it's getting less on the number line. I hope you have that number line handy. What about from negative 2 to 3? It looks like it's going to jump up if it's going to go up to 5. So really, there's no pattern there either. So some of these, it's pretty much done. You're going to just say no pattern, or no pattern, no sequence, and there's no pattern to it. Okay, well, let's look at the next one here. This one here. 43, 37, 31. Let's see. Okay, 43 to 37. Let's see. That's 3. Is that 6? So we're gonna go down by 6. Just making sure I got this right. What about 37 to 31? Let's see if I do the math right. Negative 6. Okay, it looks like I'm seeing some kind of pattern here. Well, how do you get to the next 3? So you're gonna go 31 minus 6. I'm hoping that I hope that you can kind of see what we're doing here, and not making it big huge deal. So 31 minus 6, let's see, that's 25. Okay, and then you're gonna go 25, you're gonna go minus 6. Is that 19? Just making sure, do the math right. That's, if you can't see that, let me move this over. So 19. You see how I'm keeping always subtract 6 here? And then I'm doing 19 minus 6. Okay, just making sure. Minus 6 is 13. Yep, just making sure. So these are your answers. And see how I'm always subtracting by 6. All right, so that's your answer to that. Okay. So try some more. The more you do, the better you're going to get. So on this one, it looks like we're going to go. So you're going to have to leave it this way. Now, some students, they would be like, well, why can't I go negative 38, negative 37, negative 36? You can do that. It's going to be wrong, because this is your sequence you're given. this is what you're given. This is what you're given. You can't really switch it around. You can't. It's not your pattern. So you'd be like, well, I can do that. No, you can't. Just making it look correct. It's what they're giving you. So from negative 37 to negative 38, it looks like it's going to go up by 1. From negative 38 to negative 36, it looks like it's going to go up by 2. You can be like, there's a pattern here. Because if this goes negative, oh, wait a second. This goes negative 1. And this goes up by 2. So there's no distinctive pattern here. There's no distinctive pattern. You gotta remember, be careful with your negatives. Remember, you have more negatives than this one. You have more negatives than this one. So this is gonna go up by 2. Just be very careful with that when you do this. Okay. So for the next one here, for the next one, let's see. We have 31 and 24. So let's see, 31 and 24. So they kind of think of a pattern. You can use your fingers. You can, that's looks like 7. So, but down 7 because it's going down. So, oops, down 7. What about 24 to 17? So 24, let's see, 17, that's also negative 7. So it looks like we have a rule. We have some kind of problem. All right. So we have 17 minus 7, which is 10. We have 10 minus 7, which is 3. We have 3 minus 7. I always do my 7s with the little cross in them because it sometimes my 7s look like different numbers. I don't know if you ever saw that before, but some people do. They do their 7s like that, but me, I do the 7s like that. So hopefully that doesn't frighten you a little bit there. So this is going to be negative 4. So here is your problems. So maybe on your homework, I will do something like this. Something very similar to this, and I'd be like, okay, so it's gonna be yes, arithmetic. There's a pattern. There's a pattern, and I'd be like, okay, so what's the D? D is what we call common difference. D is what we call the common difference. That difference is this right here. It's this right here. This is what we call the common difference. That's your answer. That's your answer. And the difference for this one is going to be negative 7. And then I'm going to say, okay, so what's your 3 predictions? Your 3 predictions are going to be 10, 3, and negative 4. And that's what I'm going to require you to do on your homework. I'm going to say, is it arithmetic? You're going to be yes. What's the common difference in? What's the common difference? What's the number? What's the pattern? And what's the numbers that you got? Those 3 things are pretty much what you're going to get out of this. Okay. I think that's pretty much covers this part. So hopefully that this made sense. You might need to go back and watch this video again and see what you can get from this, but I don't think that this is too bad. I think that this is very much workable. So I will see you on the next video.